Imagine jumping from Earth to a distant galaxy in seconds. No rockets, no years-long journeys, just instantaneous travel across the stars. Science fiction, right? Or is it the future of space exploration? In this video, we're diving deep into the captivating world of warp drives and wormholes. Are they real? Could we actually surpass the speed of light? And what does Einstein have to say about all this? Stay tuned to the end, because the answer might bend your mind as much as space-time itself. Let's start with the rules. According to Einstein's theory of relativity, nothing can travel faster than light in a vacuum. That's about 299,792 kilometers per second, or roughly 186,000 miles per second. Why is this the limit? Because the faster something moves, the more its mass increases, requiring more energy to keep accelerating. To reach the speed of light, you'd need infinite energy, and we don't have that. So, traditional propulsion systems, rockets, ion drives, nuclear engines, are all stuck in the slow lane compared to the vast distances of space. But what if we could cheat the system? Not by moving faster than light through space, but by bending space itself? Enter the warp drive, popularized by Star Trek. It sounds like science fiction. But in 1994, theoretical physicist Miguel Alcubierre proposed a real solution within Einstein's field equations. Instead of pushing a ship through space, the Alcubierre Drive compresses space in front of the ship and expands it behind. The ship doesn't move in the traditional sense. Space moves around it. This concept doesn't violate relativity because the ship itself isn't exceeding the speed of light locally. Instead, space-time itself does the heavy lifting. However, there's a catch. The Alcubierre Drive requires something called negative energy or exotic matter, substances with negative mass that we haven't proven to exist. Also, the amount of energy originally calculated to run such a drive was astronomical, more than the mass energy of the observable universe. Later refinements reduced this, but we're still far from having a working warp engine. But the fact that such a solution exists within Einstein's equations is mind-blowing. Now let's talk about wormholes. These are hypothetical tunnels in space-time that connect distant parts of the universe through a shortcut. First suggested in 1935 by Einstein and Nathan Rosen, hence the name Einstein-Rosen Bridge. Wormholes arise naturally from general relativity. Imagine folding a piece of paper and poking a hole through it. That's a wormhole, a bridge between two distant points. In theory, you could enter a wormhole near Earth and exit near Alpha Centauri in seconds. But again, exotic matter is needed to keep the wormhole stable and prevent it from collapsing under gravitational pressure. And time dilation adds more complexity. A wormhole might not just connect places in space, it could also link different points in time, potentially allowing time travel. But we've never observed a wormhole, and creating one would require technologies far beyond our current capabilities. Still, they remain a legitimate possibility in theoretical physics. So, can we beat light speed? Technically, no object can move faster than light through space. But by manipulating space itself, via warp drives or wormholes, we might sidestep this rule. Both concepts rely on exotic physics and materials we haven't yet discovered or produced. But scientists are actively researching these ideas. NASA's Eagle Works laboratory has explored warp field mechanics, even building small experiments to detect space-time distortions. So far, no warp bubbles, but the work continues. And in 2021, a team of physicists proposed a new model for a warp drive that doesn't require negative energy, using classical physics. It's purely theoretical, but it's progress. We're inching closer to the impossible. Why do these ideas captivate us so deeply? Because they challenge our understanding of reality. If faster-than-light travel becomes real, it would revolutionize not just space exploration, but our concept of time, distance, and causality. It could mean new civilizations become reachable. It could mean escaping doomed planets. It could even mean interstellar migration. More than that, it reminds us that the universe might have loopholes, hidden pathways that could transform our destiny. But these ideas also carry dangers. What would we find on the other side of a wormhole? What are the risks of tearing space-time? Could manipulating gravity and space have unintended consequences? With great power comes great responsibility. Warp drives and wormholes remain speculative but not impossible. They're a bold frontier at the intersection of science, imagination, and hope. As our understanding of the universe deepens, what was once fiction may become fact. Until then, we keep dreaming, calculating, experimenting, and daring to imagine a faster-than-light future. If you enjoyed this journey through space and time, like, subscribe, and hit the bell icon so you don't miss what's next. Until then, may your mind remain curious and your imagination limitless. Thanks for watching.